This video will be all about 4.3 finding missing parts using similarity to find measurements. We've already done all of this. Now we're using it to find different parts in triangles and different shapes. So there's really nothing new in this video. It's just taking the two methods that we've learned. One is using the scale factor, and the other is the ratio of the side lengths to answer different questions about missing side lengths. That's all that this video is going to be about. That's all this problem 4.3 finding missing parts is about. Okay, so let's go ahead and get into it. For questions A and B, each pair of figures is similar. We have to know that. Because they're similar, we know how to find these ratios, or we know that we can set up these ratios. And then we find the missing side lengths. Then explain how you know your answer is correct. Now the how could be, hey, I used the idea of scale factors, or I use this method with the ratios of the side length. And we're actually going to do both ways. Now there's a lab sheet that goes with this that looks like this. So let's go ahead and do it both ways. So number one, let's use the scale factor method. Okay, so let's figure out the scale factor. First of all, what we have to do is we have to figure out what our corresponding sides are. So for example, this side, it's the smallest side on that triangle. So it's going to correspond with the smallest side on that triangle. And then the next smallest would be X and 5. Those are corresponding sides. And then lastly, the 12 meter and the 6 meter are corresponding. So if we're finding scale factors, that's just a ratio of corresponding sides. So for example, if I look at the blue or green aqua turquoise side, it's 12 meters. The corresponding side is 6 centimeters on the smaller one. So that has a scale factor of 2. So 2 is our scale factor, meaning to go from the small to the large, you multiply by 2. Now I have all that I need right now to find what the value of X is. Our goal is to find that value, and I have what I need because the side that corresponds with X is 5. So to go from 5 to X, I know that I have to multiply by 2. And so my scale factor tells me to multiply by 2, so I know my X is going to be 10 centimeters. These are supposed to be centimeters here. Okay, so we can use scale factors. Here's the other one that I'm going to do. The second way is to use ratios of corresponding side lengths. So for the big triangle, we need to figure out what X is, right? So X over, let's say, 12. So yellow over turquoise, and we're going to do yellow over turquoise over here for the smaller triangle, so 5 over 6. So we're setting up ratios and then setting those ratios equal to each other, and because these are ratios that are equivalent, they are equivalent because they are similar triangles, we know that they are equal, so we can set them equal to each other. And then when we do that, we can look to see, okay, well, listen, to go from 6 to 12, I multiplied by 2. So I need to do the same on the top, because remember, when you're finding equivalent fractions, that's essentially what you're doing here, right? You're finding equivalent fractions, so in order for those to be equivalent, X has to be 10. Now on your test corrections, if you do test corrections for something like this, when you have to solve, well, on part 3, where you have to do it a different way or prove that your answer is correct, you can do it, originally do the problem using scale factors, and then do the problem again using ratios. And that would be a different way to prove that your answer is correct. Go ahead and try this one right here, figure out what X value is, and then come back to the video. So I encourage you to do them both ways. Use a scale factor and set up the ratio to make sure that you got the right answer. Okay, so check your work, see how you did. So I went ahead and identified corresponding sides using the different colored highlighters. This is tricky. Remember, shorter sides are always going to correspond with each other. So 1.5 and 6 centimeter, those are your corresponding sides. Then for the scale factor, I just set up, okay, well, 6 over 1.5, 4 is my scale factor. That gets me from the small to the big. So I'm multiplying these sides over here on the small one by that 4. So 4 times what number will give me 10? And you can just divide by 10 by 4 to get that, which is 2.5. And so my x value is 2.5. Now let's do that using ratios. So here's our proportion, setting two equivalent ratios together. So x over 1.5, and since the x is turquoise, I put it on top, the turquoise number on top over here as well. So 10 over 6. So then again, I think to myself, well, what do? Well, I multiplied by 4. But if you want, I guess on this one, you need to go in reverse. So from 6 to 1.5, you need to divide by 4. So to 10 to x, you needed to divide by 4, and that is 10/4. So x would be equal to 10 over 4, or 2.5. And again, that's what we got over here. On your tests and quiz corrections, you could do it both ways to show that another way how to do it. All right, now choose any method and solve for this one. And on this one, you're going to have to figure out not only what the x value is, but we have to figure out what all of these missing angles are as well. And I'll give you a hint. All quadrilaterals, all of the angles in any quadrilateral add up to 360 degrees. Pause the video, use any method, and try this and see how you did. Okay, so let's take a look at this. If we know, let's figure out the angles first, because I think that's the easiest. Now, if you have parallelograms, you should know that opposite angles, angles that are across from each other, are the same. So that means that this is 68 degrees as well, and this over here is 68 degrees. Now we need to figure out what these opposite angles are here, and what these opposite angles are here. All right, well, we know that the angles in a quadrilateral will add up to 360 degrees. So we're going to take 360 degrees total, and we're going to subtract away what we know. So we know these two angles are 68. And there's two of them, so we'll just do 68 times 2. 360 minus 68 times 2 gives us 224. So now between angles A and angles C, it's 224. Since we know those are equal, let's just divide that in half. That gives us 112 degrees. So we know A and C are both 112 degrees. And then we know also here, this is 112. Because they are similar to each other, they have to be the same angles. So now that we have all of our angles, let's focus on finding x. You could have used any method that you wanted to. I'm going to go ahead and use the idea of a scale factor. So if I find the scale factor, right, I'm going to go 27.5 over 12.5 and find that scale factor, which is 2.2. So that's my scale factor. Okay, so now to figure out what this value is, well, I know this is going to be 2 times 2 bigger. So x is just going to be 18.75 times 2.2. Which gives us 41, so this is going to be 41 and 1/4 meters. So our answer for x here is 41 and 1/4 meters. When you are doing this on your homework, your tests, your quizzes, make sure you have your answers clearly labeled so it's a lot easier for me to grade. If I needed to go search for it, I likely won't find it. On the last one here, we are going through and make sure, let's come back to the notes real quick to make sure that we're answering the questions. because on these questions for the parallelograms, you're just finding the missing measurements. Explain how you know your answers. So on a test quiz, if you had to explain, you're telling me the methods. Well, I used the scale factor. The scale factor was 2.2, right? So from here to here, I multiplied by 2.2. And if I want them to remain similar, I'm also going to multiply this by 2.2, which gave me 41 and 1/4. So make sure you are explaining that and know how to explain problems like this, because that is going to be part of your quiz test assessments. Now on this last one, okay, this will also jump back to our lab sheet for this one, but number one, let's find the value of x right here and explain how you find it. There's multiple ways to find that value. Okay, so find x, also find y, and explain how you found it. So go ahead and answer parts 1 and 2, come back to the video, and then we'll go on from there. Okay, so for number 1, if we figure out what the x value is, right, there are multiple ways. Number 1, you can see what the scale factor from one to the other is. So if we go from 8 to 14, so let's look at our scale factor. You would go from 8 to 14. So what is that scale factor? Give us 1 and, what is that, 1 3/4? That's our scale factor. Okay, so we know that we're going to have to take this number times 1 3/4. So it's going to be x times 1 3/4 gives you 1.75. You should see that in order, this is actually 1 3/4 is the same as 1.75. So in order for this to be true, this has to be just 1. So x is 1. Let's highlight that so we can find it in the future. X is equal to 1. And then your y, you know that the scale factor is 1.75, but let's just do this a different way. I'm going to find y using, and I'll do this in, let's do this in purple. I'm going to find y using ratios. Like for example, I'm going to take 8 to 4, and the corresponding sides would be 14 and y. So 8 over 4 is equal to 14. Okay, so here's why I'm doing this. If you simplify 8 over 4, 4 will go into both of that, 2 over 1. Okay, if you simplify that down, they're still equivalent. And you can see, hey, to go there, I needed to multiply by 7. So I also need to multiply this by 7, and so y is 7. All right, so we figured out what y was, and we figured out what x was. That was parts 1 and 2, and make sure you explain your methods, what you did, whether you set up the ratios or just use scale factors and how you use the scale factors. Then the next ones talk about perimeter and area, so let's take a look at those. First, let's take a look at the perimeter of this figure right here. And I'll use this color for the perimeter. Okay, remember the perimeter is the sum of the outside. So we're going to find the perimeter. So this is 8. So we have 8 plus, we don't know that one yet. We will figure it out. We know this is 3. This is 5. This is 2. This is 1. And this is 4. So now we need to figure out what these are. Okay, and we can easily figure those out. Let's look at this one right here. Let's look at this. Okay, well, if I take this side, and this side, and put them on a level plane, meaning I take it and move it up here, and I take this one and move it down there, it would create a line that goes straight across to there, which is the same distance as that line up there. So that tells me that when I add 1 to 5 to whatever this value is, it should equal 8. And so then that tells me that this value right here should be 2. All right, so I'm going to add 2. I'm going to use the same idea here, the fact that this plus this has to equal 2 plus 4, right? So 3 plus 3 gives me 2 plus 4, which is 6. And so this has to be 3, so we're going to add 3 onto that perimeter. And let's add all of those together. And when you do, you get 28, and that is in, is this units? Centimeters. We'll say centimeters. So that's your perimeter, 28 centimeters. Now, over here, we can easily find the perimeter without having to do any of that work, because we know the scale factor is 1.75. So we're going to take 28 times 1.75 to get our scale factor over there, and you should have 49 centimeters is our perimeter of the big one. Now, to find the areas, let's go ahead and see how you did with the areas. If you haven't tried that yet, pause the video and try it first. Okay, so I'm going to erase some of the stuff that I did for the perimeter, just because it can get in the way. So, still know my scale factor, still have all of that, but let's look. All right, now for the area, I'm going to use a different color. All right, I'm going to do something unique, a little bit different. Okay, so let's break this up into parts that we can find the area of. Okay, so for example, I'm going to extend this line here, and now this is a 4x1 rectangle, which has an area of 4. I'm going to extend this up here, which now this is a, what do we say this was? Oh, that was 2, because 5, 6, yeah, that was 2. And then this we found to be 3, and so this has an area of 6. And then over here, this is a 5 by, well, we have 8. Then from there to there was 2, right? So this was 2. And then this is 1 from there to there. And so 8 minus 3 gives us 5. So that up there is 5. Well, we should have known that already. And then total width is 6. So 5 times 6. And the area of this square in here will be 30. Now to find the total area, we add those together. So 30 plus 6 plus 4 will give you 40. Okay, units squared or centimeters squared, whatever this is in. I think it's just centimeters. So it's going to be centimeters squared. Now remember, to find the area of this one, how they're related, you would take the 40 times 1.75 squared, because the area is related by the square of the scale factor. So let's see what that is. And you end up with 12.25 centimeters squared. So that's the area. Remember, think smarter, not harder. You could go through and do the same thing that we did over here, break it up, but why do that when you just multiply it by this 1.75 squared? So now let's make sure we answered the questions. We found the perimeter and area. We did that. And then on number 4, use your answer. In part 3 in the scale factor, find the area and perimeter of the other figure, which we did that as well. All right. And then explain, so put down in words how that works. Okay, how does the scale factor, knowing the scale factor, give you the perimeter of the bigger? How does knowing the scale factor give you the area of the bigger shape? And then once you've explained that, which is really important, you can go ahead and finish work on your ace because that is it for 4.3, finding missing parts.